Okay, so where we left off on the last review question was the conversion. We're about to do B, 8.6 kilometers into meters. So you want to get rid of the kilometers, they would go on the bottom. You wanted to go into meters, they would go on the top. Kilometers is bigger, so you put the one there. Meters, 1,000 meters in a kilometer. 8.6 times 1,000, so 8,600 meters. Okay, the next one is millimeters into kilometers. So I would suggest that you might want to go millimeters to meters first. So millimeters on the bottom, meters on the top, and then meters to kilometers. So that meters on the bottom, kilometers on the top, and that will get you in the end to kilometers. So meters is bigger, 1,000 meters in a millimeters in a kilometer. So one goes on top, 1,000 on the bottom, and then kilometers is bigger, 1,000 meters in a kilometer, so 1,000 goes on the bottom. So really you're dividing by 1,000 and then by 1,000 again. And when you do this, you're going to get a very tiny number. It's going to end up being 3, putting it in right scientific notation, 3.28 times 10 to the negative 7, I think. Oh, no, I went the wrong way. Negative 5. Sorry, because it's, 3 times, so this is times 10 to the negative 5, okay? Because it would be times 10 to the negative 6 and then move it back one, so negative 5. All right, then kilometers per hour to meters per second. So again, you need 2 conversion factors so that we can end up with meters per second. First, to get rid of the kilometers, they go on the bottom. Meters on the top, 1 kilometer, 1,000 meters. To get rid of the hours, it's on the bottom. So it has to go on the top, and you want seconds on the bottom, 1 hour, 3,600 seconds. So multiply by 1,000, divide by 3,600, and I believe you get 22.7 repeating meters per second. And the last one, meters per second to kilometers per hour. So when you get rid of the meters, it goes on the bottom, kilometers on top, 1 kilometer, 1,000 meters. Seconds on the bottom, so it goes on the top. You want hours in the end on the bottom. 1 hour, 3,600 seconds. So multiply by 3,600, divide by 1,000, and I think you end up with 79.2 kilometers per hour. Okay, so there's the review sheet. Hopefully it wasn't too bad, and hopefully everything I did made sense. Now, if you look on the back, you will discover a second algebra assignment. And just to talk about it for a minute, the first ones are very much like that first algebra assignment you did. Okay, so just solving for x, even with some fractions, your favorite. When we get down to number 11, these are now like the ones on the back side of the sheet, where I want you to show me that you can FOIL, you can solve for x. For the first number of them, the x squared terms will cancel, but the last 4 you're going to get quadratics for. The 3 of these 4 you can actually factor. So 13, 14, and 15 you're going to get an x squared term, but you're going to be able to factor it, right? So what I mean by factor is, like, you'll get, I'm going to say ax squared plus bx plus c equals 0. But remember from maybe grade 10 math, you learned how to put like an x here and an x here and then figure out what numbers you put in here. So you could actually factor these and you'll end up getting, like, I don't know, I didn't make up numbers, so let's say this was x squared plus maybe 6x plus 9. And so you'd put a 3 here and a 3 here. So then x plus 3 equals 0, and you would solve for x. And then this term, it tells us I didn't do a very good job. I shouldn't have picked 9 because that makes it too easy. So let me pick, I'm going to pick 8 instead. So this would be 4, and this would be 2. So then you'd set x plus 4 equal to 0. So x is equal to negative 4. And then x plus 2 equals 0, x equals negative 2. Okay, so you factor it, and then you set each bracket equal to 0 and solve for x. Okay, so you can do that for 13, 14, and 15. But when you get to 16, it's going to give you a quadratic that you cannot factor. So for this one, you're going to have to use the quadratic formula. And yes, I did this to you on purpose so that you get to use the quadratic formula at least once for me, okay? So write it in ax squared plus bx plus c form. Pick out your a, b, and c's, and then sub it in here, okay? And your first step, of course, would be to cross multiply here, okay? 17, 18, 19, 20 are like the bottom ones in the back of the math sheet. So I want you to get the x's all on one side and then get them alone. So it won't be a number, it'll be a term. And then the last three are trig. Okay, so solve for the x and the theta, or the x and the y, and the x and the y as indicated. Please do all of this on a separate math sheet. Please do not do this on this page. There's not enough room. It'll be too hard to follow. On a separate piece of loose leaf, make it nice and neat. And it's going to be due about probably Tuesday or Wednesday. So work on it over the weekend. It's your homework for the weekend. And then you'll have time on Monday. I'll be in my room Monday at lunch, Tuesday at lunch. So if you need a hand with any of them, and the ones you'll need a hand with will probably be 13, 14, and 15, and 16. But if you need a hand, I'll be there to help you, okay? You're also welcome to ask in the group tonight or over the weekend if there are any questions. All right. Two new things. Well, not new. We were talking about random error and systematic error when you left today. And on Monday, I will give you a sheet of notes with these. But we were talking about how random error in an experiment is error like your reaction time in a stopwatch. It's error that just happens. And it's totally unpredictable. And there's not really any way we can get rid of it. But the way we minimize it is by doing more than one trial, doing as many trials as possible and averaging it in hopes of getting rid of the error. So that's random error, and we had discussed that in class today. The one we didn't get to was systematic error. And systematic error, it's like an error of the system. So it's an error in the design of the lab. So the lab where we're dropping stuff off the upper cafetorium, one of the systematic errors is air resistance. There's air resistance, there's breeze in the cafetorium from the air vents and the doors opening, and that breeze is going to affect the birdie more than it's going to affect the tennis ball. Okay, so the only way to get rid of this error, systematic error, is to redesign the experiment. We could try to pump all the air out of the cafetorium, but it kind of leads to the rest of the school, and air is kind of a vital part of all of our lives, so that's not going to really work. So it's hard to get rid of this error because of the design of the experiment. Okay, two other words that you'll often hear when we're doing experiments are accuracy and precision. And accuracy is like how good you are, how close what you get is to the right answer. So in that lab that we're doing the acceleration due to gravity, how close are your answers to what the acceleration due to gravity really is supposed to be? That's how accurate you are. Precision is more about the measuring tool. How precise can you measure something? Like how fine are the measurements? It's precision, like how many decimal places can you get? So it's always limited by our measuring devices. And that's why we have significant digits, because we're limited in how precise we can measure. So at the end of a lot of our labs, you will do something that's called find the percentage error. And the percentage error tells us how close you are, how good you were with your measurements. So you take the theoretical value. So if we were doing gravity, the real answer for gravity should be 9.81 meters per second squared. Okay? And then you put what you got, like what you got for the tennis ball, and maybe you'll end up for the tennis ball getting something like 12 meters per second squared. So that goes on the top, and then you divide it by the 9.81 meters per second squared, and you times 100. Now these straight lines out here mean absolute value, and that what that means is, doesn't matter if it's negative. Like up here, this is going to be negative when you take 12 away from 9.81, but we don't care. The straight lines say just drop the negative and just look at you're looking for the percentage, how far you are off the real number. Okay? And so again, I will give you these notes on Monday. And then there's one more video to do the new thing that I would have done in class today. Okay?